When it comes to database design, many beginners try to connect two tables directly in a many-to-many relationship, and then wonder why SQL queries don't work. The secret? You need a third table. In this video, we'll show you how to represent many-to-many relationships properly. Before we jump to the many-to-many relationships, I will need to refresh your memory on cardinality first. The understanding of cardinality is important to understand the many-to-many relationships. But if you are well-versed in this concept, you can skip this chapter and jump to the many-to-many relationship. Cardinality describes the number of instances of one entity that can be associated with a single instance of another entity via the relationship. There are two key points on cardinality. First, a relationship between two entities can be broken down into two different directional relationships when you look at it from the lens of cardinality. For example, think about the relationship between user and account in a database supporting a bank system. The relationship between the two entities are summarized in the two sentences as you can see on the screen. First, a user has 0, 1, or more accounts. Second, an account is associated with one and only one user. The two sentences represent the two directional relationships. Sentence 1 is about the relationship from user to account, while sentence 2 is about the relationship from account to user. Every relationship can be broken down into two different directional relationships like this. That's the first point. Second, a direct relationship is represented by two symbols of max and min cardinalities. The three individual symbols represent three quantities, include 0, 1, and many. The circle represents 0, the bar represents 1, and the symbol that looks like a crossfoot represents many. Each directional relationship is represented by two symbols. For example, the first sentence you saw earlier is on the directional relationship from user to account. The two symbols representing cardinalities need to be placed near account. A user can be associated with 0 accounts, so the main cardinality is 0. A user can be associated with many accounts as possible, so the max cardinality is many. The second sentence is on the directional relationship from account to user, and its cardinalities are placed near user entity. Both of the min and max cardinalities are 1. In the end, you are supposed to merge the two directional relationship as one relationship between user and account entities. After the merge, the positions of the two min and max cardinalities would be the same as if you draw them separately. From the lens of cardinality, we can put all relationships into three baskets, including the one-to-one relationship, one-to-many relationship, and many-to-many relationship. We will look closely at the many-to-many relationships next. In a many-to-many relationship, the max cardinalities of both directional relationships are many. The many here primarily refers to the max cardinalities of the two directional relationships. In other words, the name many-to-many doesn't concern itself with the min cardinalities. It can be either 0 or 1. However, we don't represent a many-to-many relationship like what you see here on the screen. Then how are many-to-many relationships represented? Think about a real-life many-to-many relationship between authors and books. An author writes one-to-many books, well, not zero-to-many, because a person who hasn't written a book yet is not an author. On the other hand, a book can be written by one-to-many authors. This is a classical many-to-many relationship. However, we don't represent such a relationship like what you see here on the screen. When such a representation is implemented, you will introduce many problems. As a starter, such a design will force each table to have a foreign key of its counterpart. Like this. After that, because an author is associated with potentially many books, you're going to store multiple foreign key values in a single book ID field, which violates something we call normalization rules. Normalization is something that's very important for you to design robust database, and we will cover that in future videos. Or the alternative is that you will end up with many redundant rows. Well, what we showed you here is not possible. You can't have several identical primary key values in either table. So basically, this representation that you see here is impossible to implement without any of the issues. Then, how is a many-to-many relationship represented? Let's stick to the same author and book example, and give them both a few attributes. Like this. The author entity, or say the author table, has 3 attributes: author ID, name, and address. The book entity has 3 attributes: book ID, title, and cover. We're gonna skip the data types here for simplicity. To represent this relationship properly, you need to go one step further by making a junction table that contains only the primary keys of the 2 involved entities, author and book. Also, you must convert the many-to-many relationship to 2 one-to-many relationships between the junction table and both entities. As you see here on the screen, the junction table, author book, contains only the primary keys from the author and the book entities. In this junction table, the book ID and author ID attributes together serve as a composite primary key. It's worth noting that the crossfoot always points to the junction table. The author and the book entities become indirectly related via the junction table. That's how a many-to-many relationship is represented. Now, you have 2 one-to-many relationships whose main cardinalities are all ones. This is theoretically okay, but not compatible with the real world, especially data entry. Think about it. When it comes to entering data into the database, the tables, you will start with either the book table or the author table, then move to the junction table. But the main cardinality of 1 requires that there needs to be at least 1 row in the author book table, the junction table, to be referenced when a row of author is added. To address this issue, you need to relax the main cardinality of the many side from 1 to 0. After that, you will no longer face problems in data entry when you implement such a design. To make sure that we're on the same page in terms of the many-to-many relationship, let's look at another example. Imagine that you are working towards designing a database for an online store named the Sci-Fi Collective, and have identified 2 entities, product and purchase. The product table represents the products being sold by the Sci-Fi Collective. Purchase table represents the order records of users. The extracted relationships between the 2 entities can be summarized as following. A purchase can have more than 1 product. A product can show up in multiple purchase records. This is clearly a many-to-many relationship, because the max cardinalities of both directional relationships is many. Note that a product doesn't have to show up in an order, so the mean cardinality from product to purchase is 0. What you see here on the screen is more like an intermediate step before we reach the proper representation. To do this right, we need the help from a junction table, and we are going to turn this into 2 one-to-many relationships between an entity and the junction table. The idea would be like this. Note that the crossfoot always points to the junction table. Beyond that, whatever you have, both the min and max cardinalities of the original 2 directional relationships will be copied and applied to the relationship flowing from the entity to the junction table. When you make all the attributes explicit, they would look like this. The last step is to relax the min cardinality from purchase to the junction table. so you won't face problems when it comes to implementation and data entry. In this video, we learned everything about the many-to-many relationship. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.